Le facteur humain reste l'élément essentiel et le premier rempart contre les menaces informatiques. On va voir ensemble comment bien sensibiliser les salariés.
my talk will look at cybersecurity risks to vehicles in the air and on the ground, vulnerabilities to cybersecurity attacks, but also defense. Specifically, it will address and look into how the technologies these vehicles use for communication, navigation, path planning, and so on, as well as all other technology that is on board such vehicles. While my talk will focus on some particular areas, I will give a very good and very broad introduction so that even if you're not a specialist on either of those subjects, you should be able to follow it.
Welcome to talk.cybercni.fr.
Bienvenue.
Welcome to the already 17th edition of Talk CyberCNI-FR. And today we have a special occasion because we are co-located at the Network Operations and Management Symposium in Budapest. And we have finally, after more than 1 year, the situation where we have more than 2 people in the audience because we are at a place where people can actually be. And that is quite nice. So welcome also everybody who is here today, and welcome everybody who is remotely following us. Today, as you see it here, we have a very interesting topic again, following our philosophy to bring cybersecurity closer to you, to make you aware of cybersecurity risks and challenges. We also ran a panel yesterday at this conference exactly about that you will also find on the YouTube channel in the next days. And we'll also run a PhD school in August that will go in the same area, where I'll also post some infos on the website once the registration is open, which will be very soon. So I just closed the messenger, but it does not click us. Okay, very good. So today we are welcoming Cora Perner, and Cora is with Airbus. Cora works as an R&T Coordinator for Cybersecurity at Airbus. She holds a PhD in computer science from the Technical University of Munich and a degree in Aerospace Vehicle Design from Cranfield University in the UK. Her research focuses on the intersection between safety and security of unoccupied and autonomous aerial vehicles, as well as the safe integration of new technologies and methods. In addition, she has published 7 papers at distinguished international conferences. Very good. Cora is also well known to those of you following the series a little bit because she was also in the last PhD school, and yeah, I know her for quite a while. It's always a pleasure working with you, Cora. And without further introduction, I would say we give the floor to you. We already heard the trailer, what you will roughly be talking about. We're really excited to hear it, and the stage is yours.
Thank you, Mark Oliver. If you could just give me a friendly wave that you could hear me all right at your end still. Excellent. So thank you for the introduction. So I'm going to talk today about security for vehicles on the ground and in the air. Now, obviously, as you can guess from the slide templates, the vehicles in the air are a bit closer to home for me. But notwithstanding some of the, if not all, as we are going to see, of the problems that are challenges that we see in these are also relevant for vehicles on the ground. And we're working together with partners in various projects on developing solutions for both ultimately. So, mainly how my talk is structured, I'm first going to go through the basics. If you've been to previous lectures of this series before, you might know some of it, but just if you're in cybersecurity, you know probably a lot of it, but just so that also the audience who might not have a background in cybersecurity has somewhere they can pick up, and it's not just technical gibberish for them. Then I'm going to talk a bit more in detail about communication. What does it mean for vehicles? What is vehicle communication? What are the challenges? What are the methods we achieve that? And finally, I'm going to talk a bit about autonomy and what increasing autonomy of vehicles means for us as cybersecurity researchers. Now, to begin with, what are we using the vehicles for? So in general, it can be divided into three subcategories. The first one is sensing, the second one is transportation, and the third one is for emergency use. Now, sensing can be for infrastructure inspection, for example, of power lines or of bridges, where it's inconvenient or dangerous for a human operator to go, or they have to go dangling in heavy equipment. So it's much easier if you can just fly UAV there with a camera and do the inspection and be safe on the ground and just look at the screen. The second one, which is even more dangerous, is the mapping of wildfires, which unfortunately we've been having a lot in recent years in Europe and also in the US, for example, where you really want to see how what's the extent of the fire, and obviously with smoke. There have been vehicle or occupied flights being used in the past, but it's very, very dangerous. So that's also where we want to move more towards autonomy, just for safety of operators and crew. In terms of transportation, this is a topic that most of us are familiar. So we want to get from A to B, but we don't necessarily all enjoy driving, but all want to do some side tasks. So increasing autonomy, or just ultimately getting safe to our destination is a goal. So we want to transport passengers, be it in sort of flying vehicles, be it in cars, be it on buses, whatever you want to go. And then, of course, goods, in the case of Amazon and all the big delivery companies are trialing UAVs to deliver their packets in cities, because it's complex with cars and expensive, and they have to find parking spots and usually park in the third lane. So there we want to just transport people or goods safely from A to B, but obviously we don't want them to hit anything, and we don't want them to be hit by anything. And a sloppy definition. In terms of emergency, there are, again, similar to sensing, we're doing it for search and rescue. So if you have a person who had an emergency but don't exactly know their precise location, you might have to cover vast areas which are impractical from the ground, or so you need vehicle support. Then there are some interesting use cases for emergency connectivity. So when there has been flood damage or other weather phenomena that brought down standard connectivity, that you can have ad hoc nodes that the emergency responders can connect to, so that it can coordinate their mission. And then, of course, there is transportation of critical goods, for example, medicine. In the pandemic, there has been also a lot of use for vaccines to remote areas, or areas where you don't want, which didn't have COVID yet, so you don't necessarily want to bring the virus with the vaccine. For that has time to work. So everything that's also in Africa, where there are, or Southeast Asia, where there's poor road infrastructure, and vaccines have to be stored at a given temperature, and the container can only insulate it for a given time, then that's also an application where you want to have autonomous vehicles. And of course also for transporting organs when you want to travel through a city quickly. So this is basically the kind of applications we're looking at. In terms of key security definitions, my apologies to all the security researchers in the audience. but these definitions are really key for the following slides. So I'm going to go through them. So in these, the CIA, so confidentiality, availability, and integrity, is the holy trinity of cybersecurity, and these measures are very, very broadly used in defining the security necessities and security requirements for a given system. And integrity basically means that the data or the information or the system hasn't been compromised, so that you know where it's coming from. Availability means that it's provided in the intervals and in the quality that you expected and that you need it to be. And confidentiality means that nobody other than your entire recipients can read the message. Now, for safety critical applications such as vehicles, today typically we tend to focus on availability. So we have in aircraft, for example, we have triple redundant, quadruple redundant systems of the most critical hardware and software. So for example, everything that's flight critical. So without software or hardware without which you can't safely fly. But if we are moving towards more and more connected systems, these cybersecurity measures are becoming of increasing relevance. And that means that you also have to make sure that your message hasn't been tampered with. That, for example, you don't, if you receive a message that an incoming vehicle is approaching, and that you need to make a detour to this vehicle, that the vehicle is actually where it claims it is, and doesn't just provoke an unnecessary detour. And for confidentiality, obviously, you don't necessarily want, for example, the car manufacturer to know where your vehicle is parked at night, or which routes you take routinely, or which payment, if it's a taxi-like service, which payment you use to gather that. So why are we talking about vehicular security in specifics? So as these systems become more and more connected and more interconnected, not only between each other, but also with services that, such as payments, such as the internet, might want to stream a video while you're driving on the motorway, or your passengers might want to stream a video while you're driving along the motorway. So you need, how do you get that connectivity from? So as you open up more interfaces to the general internet, of course, your attack surface, or the possibility to be attacked, is vastly increased. Not only because instead of using an obscure protocol that about 5 people in the world can program on hardware that's been out of date for 15 years, you use standard components, standard programming languages that have inherent vulnerabilities, and that are vulnerabilities that are known to a wider field of people. With that connection, you allow attacks to propagate, not only to the vehicle that has the interface, but with vehicles and with the infrastructure being increasingly connected. You can also allow attackers to propagate through a network, through a system, excuse me, and just be more at risk also on vehicles, and not just on your mobile phone or on your laptop. So what's more is that connectivity is becoming critical for many functions. So unlike in the past, where connectivity to a certain service was an option and it was nice to have, but you didn't really lose any critical functionalities when you didn't have that connectivity. For more and more functions, especially in the automotive world and for cars, that connectivity is really a necessity for functions, for example, to allow manufacturers to update vehicles, to provide new software, for example, when there is a new speed limit at a certain region. So obviously, if you don't have that speed limit, it's that up-to-date speed limit for a different, you're speeding, and that's a danger to yourself and others. So lack of this connectivity is a safety risk. And that means that as an attacker, with jamming or spoofing of a communication link, so either blocking that port by sending enough data or by claiming different data. So, for example, pretending there is a speed limit of 50 when in reality it's 40 or vice versa. That means that the probability and the impact of an attack is vastly increased. And moreover, with what I mentioned briefly earlier, with more vehicle-specific implementations are being phased out, there is a probability of, similar to what we've seen in the past with the vulnerability on Siemens PLCs, even if you're not the target of a cyber attack, just because you're using the same infrastructure, the same technology, you could still be vulnerable to and still face an impact on your computers, on your equipment, even if you're not the target, and even if the attacker didn't specifically want to impact your device. So what that means for us is that all risks that apply to a computer equally applies to a vehicle. And in addition, if a computer has a serious problem, you can shut it down. With vehicles, you need to bring them to a safe stop first. And obviously, if you have a serious impact driving 160 on a German motorway, that needs time, and your systems need to be sufficiently robust to handle that time necessary to bring the vehicle to a safe stop without possibly while facing a cyber attack, which is something that makes this domain much more challenging than when we look only at computers. So to go to the basics of vehicular communication, what are we using it for? We are either using it to communicate from vehicle to vehicle. So, for example, if you're considering an autonomous driving scenario, that the vehicle in front of you has to brake very hard, so you should you need to brake hard as well. There's an emergency up ahead. Communication like that, or with flying vehicles to negotiate if you're on a potential collision course, how you're going to safely navigate around each other. Then there are vehicle to ground communications. Sorry, that's aerospace domain. Or vehicle to infrastructure would probably be the all-encompassing term. So basically, when you, like in the example I gave earlier, if you have a software update, for example, on a vehicle, some added functionalities, or if you, for example, in the flight, why is it not sharing my screen anymore? Interesting.
Yeah, so your screen share stopped, but it just stopped right now. Okay, let me just quickly set it up. Okay, but wait a second. Okay, we're back to you.
Thank you. I don't know what happened there. So